So in the final video of this RIPEMD-160 GoLang implementation series, we have final value construction and output. And so just a quick review, we did input and processing, compression, and now we're doing final value construction and output. Jumping into our code here, so we're on to this last step. We have all of our values, and now we're passing that to our final hash values in hex. And a little bit different from SHA-256 here again. So we're creating our byte array, and then first we're passing our hash values in that we got from our compression function, and then we're creating our empty byte array to add those hash values to it. And here's where it differs from SHA-256 again. And so this is also little endian. These are all little endian values. So we have our binary values being added here, and so the final value for the first 32 bits, I should say, are being added in little endian, and that's our first hash value. And so we add all of those together. We concatenate them together like we did in SHA-256, but this time, instead of doing it in big endian, we're doing all of those values separately. So they're each 32 bits, which is 4 bytes, but those bytes are all in little endian order. And then once we have that, we construct it into a single hexadecimal value, and we print that to standard out, which is what these two lines are doing. Those go to standard out. So we can just test this. Go run RIPEMD-160 example implementation, pass it ABC. There's our output value, and then if we go echo truncate ABC, open SSL, and we'll go RIPEMD-160, and our values match. And then we discussed in the last video. And then, as I mentioned in the last video, the previous video, we can also bring up the RIPEMD specification and have a quick check against that too. So we pass in ABC, and this is the value that they're specifying, and we can just copy paste that, and sure enough it matches the other two commands that we just gave it. And so that wraps up the GoLang implementation of RIPEMD-160. I hope you found it useful and insightful, and hopefully it gave you some idea of how this stuff is working, like the SHA-256 implementation did, and you can use kind of what you've learned, especially with the logical functions and how those bitwise operations are scrambling up the input bytes. You can look at how that process works, and you can apply a lot of those same principles and techniques to many different places within the Bitcoin system. So hopefully you recognize those as you work your way through more of this learning material, and it helps you out.